All right, let's look at this roller coaster example. So I have a 1,500 kilogram roller coaster car moving at 21 meters per second at the bottom of a valley with a radius of 20 meters. What is the normal force supplied by the track? So I get this roller coaster car flying through this valley and I want to know what's that normal force on it. So it isn't actually making a full circle, but because it's going through part of a circle, we can consider it circular motion, and we can go ahead and apply our rules for solving these problems. So first thing we need to do, draw a free body diagram. I have the normal force and I have gravity. Next, I need to identify the direction of AC, which is always radially inward, and I label that my positive direction. Now I can sum up the forces parallel to the radius, set it equal to MAC. And inside that AC is where that speed they gave me, that 21 meters per second, is going to go. So I see over here I have normal force minus mg equals MAC. Go ahead, solve for normal force. So normal force equals mg plus MAC. But we're going to again substitute in v squared over r in for that AC term. So they give me the mass, they give me the speed, they give me the radius of that circular motion, which was the 20. Go ahead, plug in your numbers. So I have 1,500 times 9.8 plus 1,500 times 21 squared over 20. Plug that in on your calculator and you should get 47,000. It's a big number, 47,775 newtons. All right, let's go ahead and climb up to the top of the next hill. All right, now that we got to the top of this hill, let's go ahead and say a second hill has a radius of 15 meters. What is the maximum speed the roller coaster can go over the hill with? So we're looking for a maximum speed. So what happens here, and I don't know if you've had this experience before, but when you go over the top of little hills, whether it's in your car or a roller coaster, you'll get those butterflies sometimes, and that's because you have this feeling of weightlessness. You're apparently weightless. And apparently weightless, if we think back to elevator questions we did before, that's when the normal force equals 0. So when Vmax occurs, it's when the normal force equals 0. And we're saying maximum velocity here in a roller coaster situation where it's not actually connected to the track and you're not bolted in. Meaning that if it wasn't connected to the track and you went any faster than that, you would fly off the track. Okay, so this is kind of the key moment here. So you might want to put a little star next to that in your notes. The idea that if we reach a maximum velocity, it's when the normal force equals 0. So go ahead, draw a free body diagram, identify the direction of AC as positive, generate our equation. So we have the sum of the forces parallel to the radius set equal to MAC. Normal force, negative normal force plus mg equals MAC. The reason it's this way is because normal force is pointing in my positive direction, so down is positive, so mg minus normal force. Now, in this situation, we are trying to find the maximum speed. So in doing so, we are going to cross that out, and we're going to substitute in Vmax squared over r over here. Okay, so let's go ahead and finish this up. So I have mg equals m times Vmax squared over r. The m's cancel. Good, it doesn't matter who's in the roller coaster car with you, the max speed is going to be the same. And so my final is the max velocity is going to be the square root of grr. And so if we plug in our numbers here, the 9.8 and the 15, you should get a max speed of 12.1 meters per second. Now, if you're a daredevil, kind of a side note to this is if you were going to do a loop-de-loop with a roller coaster that was not connected to the tracks and there was no seat belts, and you want to know, well, what's the minimum speed I can go through this area? And so we have normal force, we have mg, and the faster you go, the bigger that normal force gets. So over here, the minimum speed is when the normal force equals 0, when you're underneath that, okay? And that's the same for if I take this stopper on a string here and I whirl it around, the minimum speed that I can have it moving at the top and have it still in circular motion, because if it goes too slow, that tension goes to below 0, it goes to 0, and it doesn't make that circular motion anymore. So I want that point when that tension was exactly 0, okay?